Greetings and welcome, friends. Mr. Waddy here. We were talking about factoring special products Friday, and the formula, the pattern we were using is called the difference of squares pattern because there's a subtraction difference, and these are two perfect squares, and they are equal to a plus b times a minus b. This pattern should be familiar to you, or the flipped version of it. Today's the 19th. Because we used to use it in the other direction where we would multiply these and end up over there. Today I'm going to factor it and bring it over here. And so in order to match the pattern, I get suspicious this might be a pattern when I realize, hey, this has two terms and my pattern has two terms. And then I realize these are perfect squares and 25 and 4x squared are perfect squares. So now in order to use the pattern, I've got to say what A and B might be. So I ask the question, what squared is 25, right? What would A have been if A squared equals 25? And you get 5. And then B would have been, well, what squared is 4 is 2, and what squared is x squared is x. Yeah. Oh, slow down, slow down, slow down. We got to make sure our friends are good. I know you just did this morning, but here we go. So now I'm going to just plug A and B in for these values over here, right? 5 and 2x. So A plus B is 5 plus 2x, and A minus B is 5 minus 2x. All right. So that works just dandy. Right? Okay, let's see. For this one, this matches a pattern. These are both perfect squares. There's a difference. So my A will be the square root of 16, which is 4, and that's x. And 169 is a perfect square. That's 13 squared and 13y. And even though there's like different variables here, you still can use the pattern. It's versatile. So I'd have 4x plus 3y and 4x minus 3y. All right, so that's how these problems ended up working until we got to what happens when there's an equal sign. And just like the previous factoring problems, we're going to use the zero product property. I'm going to set this equal to 0. Yeah. So now that it's equal to 0, I would now try to factor this, and this happens to be a difference of squares pattern. If it wasn't a difference of squares pattern, I would have tried factoring using other techniques. Actually, in a couple chapters, I'll show you a third technique on how to solve this exact equation if we want it. So let's see. Let's figure out, okay, difference and perfect squares. So A is 2x. The square root of 49 is 7. And actually, no, I don't even worry about that because the plus or minus is going to take care of it anyway. I would recommend writing the minus 49 because you need the difference for the difference of squares pattern. I would write it in standard form if I could, or with a positive leading coefficient. You should rearrange it. I mean, you might have kind of like just used the pattern and kind of kept going. But as far as like making sure that each step is kind of mathematically making the most sense, you should rearrange it there. So let's see, two things multiply to be 0, therefore one of them equals 0. So 2x plus 7 equals 0, and 2x minus 7 equals 0. And now these are solvable with our old school algebra problems. And yeah, these will be fractions, but at least the fractions don't show up until the very end. So I get x equals negative 7/2. What am I doing? Why did I put that in parentheses? There we go. And over here, I'll get 2x equals 7 and x equals 7/2 when we're all said and done. Right? So, yeah. Right? You just solve normal. So our process is the same as it's been since we've ever been solving quadratics. Set it equal to 0, factor, set each factor equal to 0, and solve using the regular algebra. Let's see, and I think I've got one more problem where this other type was, what if it is has two terms, but they aren't perfect squares? There's a chance, now not always will this be the case, but there's a chance that you can use GCF to deal with this. All right, this 2 is not a perfect square. 50 is not a perfect square, but it turns out anytime I'm factoring a problem, the first technique I should try is see if I could steal the greatest common factor from both of those, in this case being 2. So I'm going to have 2 times m squared minus 25. Yep. And so notice this inside is a difference of 2 perfect squares, where a would have been m and b would have been, what squared is 25, you said? 5, I agree. So those happen to be perfect squares after I used GCF. So this 2 is still going to be on the outside, mind you, but these two parentheses will be a plus b and a minus b, as always. Yeah, so you got to keep, that 2 is still there. That 2 is still there, so make sure you don't forget it. All right, thanks for watching, Internet friends. Have a great day. Bye-bye.